All right, guys. So we're going to cover a different concept based on what you learned about elasticity of demand in the one prior. Okay, and this concept is on total revenue and elasticity. Okay. When I say total revenue, what I'm referring to is the effect of price times quantity equaling total revenue. So let's say your price is $1. Let's say you sell 2 units. It means your revenue or how much money your business has made is $2. The reason this matters is because it's relevant to how elasticity behaves, particularly elasticity of demand. So whether something's elastic or inelastic will have a different effect on how total revenue is actually calculated. And the way I think about this is in 3 categories. In the first one, if something is inelastic, what generally happens is your change in quantity demanded is less than your change in price. And what this leads to is revenue increasing overall. We see this with the gasoline example, the insulin example. Companies can set a higher price and therefore have a higher total revenue. If you have something like a unit elastic demand, usually it's like a 1-to-1 ratio as we described before. So your change in quantity demand and your change in price are equal. And what that leads to is generally no change in total revenue. So since we're substituting evenly. The other one is elastic. And what happens here is your change in quantity demanded is greater than your change in price. And this leads to a decrease in total revenue. Kind of keep these in mind. I like to see these in a visual format, and I'll kind of draw that out for you below in this graph. So this right here is your traditional demand curve. This is your quantity, this is your price. Right here, where your price and quantity are equal, is where we explore unit elastic demand. To the left of this, we will end up with elastic demand. And to the right of this, we'll end up with inelastic demand. So that's kind of this portion right here. And this graph actually projects very well onto this other graph on total revenue and quantity, kind of showing you the relationship. So whatever we've kind of discussed here, we can represent in the graph below. So you have the highest revenue when you're at unit, or when you're approaching unit elastic. You have you're approaching a higher revenue source as you move from the left to the right from here, and this is your elastic portion. And then as you go this way, you end up with something that's, generally speaking, more inelastic. Okay, and that's in sense of total revenue. And you can kind of work through this in the table that is provided to you in your slides, and it'll give you a better representation of this as well. However, what we're going to do now is get into some of the other types of elasticities that we did not cover in our previous video. First one is income elasticity of demand. Our way of representing these formulas is going to remain fairly even, but let me give you a definition and then I'll write down the formula. So this measures quantity demanded changes when income changes. The formula for this is truthfully y Y represents income, E is still elasticity, D is still for demand. YED, percent change in quantity demanded over percent change in income. So kind of looks like this. And what we end up with is if the value you get from your YED calculation is greater than 0, we call that a normal good, as you might have gone through in some of your previous lessons. So what this means is, as there's an increase in income, people buy more of that particular product. If your YED is, in this case, negative, we call that an inferior good. And what this leads to is, as income rises, for inferior goods, people buy less. So an example of this would probably be, if your income goes up, you might start consuming more restaurant food. However, if your income goes up, you're gonna most likely start consuming less cup noodles, right? Like those noodles that you get in those cups, and you can eat them after putting hot water in them, or something like that. Something that's considered generally cheaper as your income goes up. So, sorry, an example of this, if we're gonna kind of put it in here, is if a family's income increases 20%, so that's the change in income, and their restaurant spending rises from $100 to $130, which is roughly a 30% increase in quantity demanded. What that leads to is a 1.5 point increase in consumption of restaurant goods. And what that means is, therefore, eating at a restaurant is considered a normal good. If I gave you another example, let's say that as income rises for this family by 20%, their consumption of cup noodles falls by, let's say, 10%. That means your number is going to be negative, 0.5. And that means cup noodles, in this case, would be considered an inferior good. So that's kind of how you can work through an income elasticity example in a more, I would say, condensed sense. The other sort of elasticity I want you guys to be aware of is cross-price elasticity. And we represent this as XED. So what we do is, instead of using income, we're comparing the price of another good and how that changes. Okay, and I'll kind of break this down in terms of what it measures. So it measures how the demand for one product reacts when the price of a related product changes. Okay, so you can think of, like, if Coke and Pepsi's prices change, what effect will that have? If coffee and cream price changes, what effect will that have? What about apples and laptops? How are they related? That's kind of the theme we're getting towards here. And if we're going through the formula, it's XED is equal to percent change in quantity demanded of good A. So you recognize whatever your good A is, and then your percent change in price of good B. And what the values you get from this would be representative of this. So if your XED is greater than 0, it means your products are substitutes. And this is like an example of Coke and Pepsi. Okay, doesn't matter too much which one you consume. You're gonna substitute between them evenly. So depending on the price. If your XCD is negative or below 0, it means your goods are complements. An example of that would be coffee and cream. If the price of coffee goes up, it'll affect the purchasing power or the purchase of cream, and if cream goes up, it'll affect how much coffee is being purchased. Both goods are complementary. Last one is if your XCD is equal or very, very close, I would say, to 0. You can use decimal forms in this case as well. We just say these goods are unrelated. Okay, so an example of this is, how are apples related to Apple products? We should find that when we did this calculation, our value should be a pretty small decimal. So you can kind of gauge, because getting a value of 0 is extremely difficult, but generally speaking, you can kind of use this to gauge where things are going. All right. The last one we're going to talk about is price elasticity of supply. So what this measures is how much producers can change the quantity supplied, so QS, when price changes. Okay, how do you calculate this? We use PES, so we replace the D with the S. And again, it's a percent change in quantity supplied over percent change in price. An example of this, if a bakery increases, let's say, their prices by 10%, as a result, what happens to the production of, let's say, bread? Okay, may go from 100 to 120. Because remember, your supply curve looks like this. So when prices go up, quantity supplied also goes up because producers want to make more, right? So in this case, I'm saying change from 100 to 20, which if you do the calculation is 20%. And 10% is your change in price. So if we kind of plug this in, 20% is my change in quantity, 10% is my change in price. This leads to a value of 2. And 2, in this case, if you think about those different ranges of elasticity we talked about before, would represent something that's more so elastic. You follow a similar, I would say, range as we did with our elasticity of demand. But the difference here is our graphs are just flipped. So our unit elastic line now looks like this. So it's an upward sloping line rather than a downward sloping line. Our perfectly elastic line now is going to look the same, hasn't changed, it's going to look like that. Our perfectly inelastic line is going to look like this. So once again, similar. However, where you do see the difference is your inelastic, right? So your inelastic line is going to look like this, and your elastic line is going to be a little bit flatter. It's going to look like that. And in terms of attaching numbers, it's similar to what you guys saw for the ones before. This is infinity, this is 0, this is 1. Hence, this one is between 0 and 1. This one's between 1 and infinity. And you can kind of work through the logic of where something would fall in terms of what you've actually calculated. And you can use your example from before and kind of follow the same scaffolding. Once again, if you have any questions, we'll definitely address them in class. But I think we'll end here for the rest of the lesson. Kind of gone through each of the points. And the point here is that you can watch this, review it, especially the calculations, so it becomes a little bit clearer for you guys.